Hello, class. This is the second part of the section 2.3 video. And the learning objectives, remember, is this will cover the last two. That is, we use a graph to locate local maxima or or local minimum values. And also, we talk about the absolute maximum and absolute what minimum. Okay. Now, I want to mention that absolute is the same as global. Okay. Global minimum and maximum. Okay, so let's look at this definition. And in the definition, don't get too confused with the lot of it's wordy. Okay, has a lot of words there, but I want you to focus on one or two things. That a function, okay, a function has what? It has an open interval or domain. Okay, so this is an open interval. The book doesn't have it, but I thought I'll put that there to help you to understand this. Now, in any open interval, if it happens that if you take the function value at c, there's a c in that open interval, and it is greater than every x, the function value at every x in that open interval, then the f of c is what we call the word local maximum value. Okay. On the other hand, if the interval the open interval contains a c, and then you evaluate the function at c, and then also at any other x in that open interval, and f of c happens to be the smallest, then it is local minimum. And so what you want to get from this is that there is an open interval, and then there's a c in that open interval, that the function value at that c is less than any other x value, the function value at any other x value in that open interval. If it happens to be the largest, then it is what? Local maximum. If it is the smallest in that open interval, it is what? Local minimum. Okay, so in a graph, this is what we see. Look at the graph on the left. Okay, the I here is an open interval. As you can see, let's say this is A, and that is B. The interval in this case is going to be AB. Now you realize that C is in the interval. See, C is in this interval, and therefore the function value at C, which is f of C, happens to be the largest. Therefore, this is what? This is a local maximum value. Or you can say that there's a local maximum value at C, and then the function value is what we call the local maximum value. On the other hand, if you have A and then B, okay, where you have that, okay, and you have this is also your B, this is B, okay, that is A, that is A, that's B. Now it's still the open interval, AB, and then C is in that interval. And this point, okay, the function value at that point is the smallest amount of, the function values at what? The A and B. Even though in this case, it doesn't exist. That's why there's a hole there. But in the definition, if f of c happens to be the smallest in that open interval, then that is what? A local what? That is a local maximum, sorry, minimum at c. Okay, now I want to mention that local maximum and local minimum, they cannot occur at endpoints of any graph. Okay, now this concept I want to mention that is going to be you get to know more about it when you get to Calc 1. All right, but here we are giving an introduction. This is how I explain to my calculus students, and I'm doing just that here. Okay, here is an example. It says that we should find, okay, we should find the what? Find the local maximum and local minimum from the graph given. All right. Now notice that, look at these points. Okay. Look at these points. All right. I want you to know that we'll talk about it. Said at what numbers x, if any, does the f has a local maximum? Then list the local maximum value or values. And then B, at what numbers x, if any, does the function f has a local minimum? And then we have to list them. Okay, so here is what is happening. Now look at the interval, the open interval from -3 to -1. Okay, now you see that there is what? The function value at what? At -2. Okay, the function value at -2, you will notice that there is what? The function value at -2, it is smaller in that interval, because if x is -3, it is this point. X is -1, it is also at that point. Okay, so there is a local minimum here, local minimum value there. Then over here too, that's between the interval, say 0 and then 2. Okay, there is a local what? Minimum. All right, so there to here too, we have what? Local min. Okay, and then also between -1, between -1 and say and +1. Okay, this function value, which is what? 3, happens to be the highest or the largest within that interval. Therefore, there's a local what? Maximum. All right, so this question says that f has a local maximum at x equal to 0 because, all right, we have f of x is less than or equal to f of what? F of 0 for any value of x in that open interval -1 and +1. And therefore, the function, the local maximum value is what? F of what? F of 3. F of 0, which is equal to 3. Okay. Now, like I explained before, we have what? Local minimum. Sorry. Okay. We have local what? Minimum at what? X equal to -2 and then x equal to what? +1. Okay. So f of -2 is what? -1. F of what? -1 is what? 0. So these are the what? Local minimum what? Minimum values. Okay. All right. Now here's a definition for absolute, which is also the same as what? Global. Okay. Global maximum or absolute what? Or global what? Minimum. Now it says that a function f, all right, is defined on some interval, and here I want you to note it is over the entire what? Domain of the function, over the entire domain of the function. Now if I go back to this, the domain of this function here is what? From positive infinity to what? Negative infinity to positive infinity. That's the domain of the function. Okay. Right. So let's talk about the absolute maximum and the absolute minimum. It's over the entire domain. The function f defined over that entire domain. Okay. Now, I want you to pay attention to this part. Okay. It said if f of u is the largest function value over the entire domain, then that function value is what we call the what? Absolute what? Maximum. Okay. And then if it happens to be f of v is what? The smallest, is the smallest function value over the entire domain, then it is what? It is called the what? The absolute what? Minimum. Okay, so let me repeat this. That to find the absolute maximum or minimum, your interval must be over the entire domain of what? The function. And then the largest value, okay, is called the absolute maximum. The minimum value or the smallest value is called the what? Absolute what? Minimum. Okay, unlike the global, sorry, the local maximum and minimum, it is not over the entire domain. It is over a section of the what? A portion of what? The domain of the function. Okay, all right. Now, let's, from this graph, as you can see, the domain of this function is what? It is what? The from A to B is close. Okay, A to B, because these are included. The at A and B values are included. Now over the entire domain, we see that this has what? This is the largest, okay? This is the largest what? Largest value of the function. Now, if the largest value, then is what? Absolute what? Maximum. Okay, that is why f of u is the what? Absolute maximum. So in other words, we say that there is absolute maximum that occurs at what? X equal to what? U. Okay, now what about absolute minimum? Well, now look at this portion where there's a V, because over the entire domain, this is the smallest. Okay, this is what is the smallest function, what? Function value. Okay, the smallest value of the function. So it occurs at V, that's in Victor, then that is the absolute what? Minimum. Now, I want to mention that it is possible to have absolute maximum or minimum occurring at what? The endpoints, in this case at A and B. But these at A and B, okay, at A and B don't happen to be the what? The largest or the smallest value of the function at all. So you cannot have, in this case, maximum and minimum, or absolute maximum or minimum occurring at the points. Okay, we have an example to show you. Now there's a theorem that says that it's our extreme value theorem. Okay, again, you hear about this, you come across this again in calculus 1. So if a function is continuous, okay, if a function is continuous, what do we mean by continuous? That if the graph, you can draw the graph without, okay, there's no hole, you can trace the graph without lifting your hand. So if I draw the graph like this is what? This is continuous. Okay, you understand this. You understand this when you get to a calculus. Okay, it's continuous. But if you have this, if I'm lifting, I'm drawing this graph, and then I do like this, this is not continuous. See? So this is discontinuous. This is discontinuous. Okay. So if the function is continuous over a closed interval like this, okay, then there is a function, the function has absolute what? Maximum and absolute minimum over that closed what? Interval. Now, when this happens, this is what we do. In this case, absolute maximum or minimum is the largest or the smallest value of the following list. That is, you have to find the function value at the local maximum and local minimum, okay, in the interval AB. And then you evaluate the function at A, you evaluate the function at what? At B. Okay, the largest of them is what? The absolute maximum, and the smallest is the absolute minimum. Okay, now I want to mention that it is possible in this case, or in this section, to have what? Both absolute maximum or absolute local maximum occurring at the same point. The same way you could have absolute minimum and local minimum occurring at the same point in the graph. Okay, so here are some examples. Now, this question says that we should find, okay, the absolute what? Maximum and absolute minimum values from the following what? Graphs. Okay, so first, look at this graph carefully. What is the domain? Okay, the domain is what? The domain is the interval AB. Okay, it's AB. Now, if it's by the extreme value theorem, it says that if you have a closed interval like this, then you have to find the function value, okay, function value at the endpoints, all right, and also at the local what? From the graph, we can what? We can find where you have where there's a curve, the curve what? It turns, okay, where we have a turning point, okay, we can have the turning points at what? Um, uh, uh, sorry, we can have the local minimum and maximum at the turning points. All right, so take note of that. So what happened is that there's a closed interval. So as we can see, let's find the what? The function value at the turning points. Okay, the function values at the turning points. Okay, so in this case, we have two turning points. We have what? At x equal to 1 and x is equal to what? 3. So we have f of 1 is what? Is 3. You have f of what? 3 is equal to what? 6. And then also, that is 1. Also, you have to find the function values at the, sorry, at the what? Endpoints. Let me erase that. Okay. Function value at the endpoints. Okay, function values at what? The end points. So we have to find a function value at what? What's my a in this case? Okay, this is the interval 0 and 5, right? So my a is what? 5. My b is what? My a is 0. My b is what? B is 5. So f of 0 in this case is what? Is 4. Then f of what? 5 is 2. So among these lists, you have, this is your 1 and then 2. We have 3, 6, 4, and 2. The smallest, okay, the smallest is at what? The smallest is at where? The smallest is at what? X is equal to 5. X is equal to 5. So f of what? 5, which is 2, is what? The absolute what? Minimum value. Okay. So that's absolute minimum value. Okay. Now, and then what is the largest? Is at x is equal to 3. Okay. So the absolute maximum value is equal to, in this case, is what? Is 6, because f of 3 is what? Is 6. Now we can also have what? Local. All right, this point here, it is both what? It also local. We have what? This is the absolute what? Maximum. It also has a local what? Local maximum. Okay. Now there's only one local what? This point, it is what? The local minimum. All right. So we have local minimum value is what? Is 3. And then local absolute maximum and local maximum value is the same. That is 6 at x equal to 3. And then also we have what? Absolute minimum value at what? X is equal to 5. And that value is what? Is 2. Okay, so as you can see, among these, the largest is what? Is 6. So that's why we have the absolute maximum. And the smallest is what? 2. That's why we have an absolute what? Minimum. Okay, like I mentioned before, we can have both what? Absolute and then local values occurring at the same point. And here is an example. All right, let's consider the next graph. Now, for this graph, what is the domain? Okay, the domain is between what? 1 and then what? 4 inclusive, but it does not exist because there's a hole. Okay, there's a hole in the graph. So you can say this is not continuous. All right, there's a hole in the graph, in the domain. All right, so what is does it have absolute maximum? Yeah, if this is not, there's not hole, if this doesn't exist, then there's an absolute what? Maximum. Okay, here there is no absolute maximum value. Okay, no absolute maximum value, because f of what? What do you call it? Does not exist. See that? Does not exist. It's not part of what? The domain. All right. Then do we have absolute minimum? Yes. In this case, there is what? This is the lowest point, the lowest or the smallest function value that occurs at x equal to what? S equal to 1. Okay. So we have what? The smallest value of f of x is what? This, and therefore that is what? Absolute what? Absolute minimum. Okay. Now there is no local maximum or minimum what values, which also we say that local maxima or minima. All right. In this case. All right. Next example. Consider this function here. Okay. We consider this carefully here. Well, what is the domain? The domain is what? It is from what? 1. This is 1 here. The domain up towards 6, but there is a hole, so we don't include. So if I write in the interval notation, it's going to be the domain will be the same as well. From what? From 1 to 6, close, like that. Okay. So this is not a closed interval. It is an open. All right. Therefore, now from the graph, this is the highest point. All right. The highest point, and therefore there is what? This is an absolute what? Maximum value. There is no local maximum. All right. Because it's at the endpoint. Remember, I mentioned that you cannot have what? Local minimum or maximum values occurring at the endpoints in the domain. Okay. Now, but we know that when x is equal to what? 2 and s is equal to 4, we have the same function value, okay, which is equal to 1. All right. So f is equal to f of 6. It is what? Is 3. So that's what we say we have absolute what? Maximum there. Now at f is equal to 2 and 4, the function value is the same. All right. So we will say that the absolute minimum is there. It's at what? At 1. So notice that the absolute minimum occurs at what? Any number in this case. All right. Does it have the locals? Okay. The function has a local minimum value at 1. Okay. It also has a local because within the interval, this is the smallest value of the function. Okay. But it has no local what? Maximum. So no local maximum. So no local what? Maximum value. But it has what? Local what? Minimum at x equal to 2 or x equal to what? 4. All right. Then finally, I think we have another graph. Now, what's the domain of this? It includes what? X equal to 0 and it goes to infinity. This continuous, so we don't know where it's going. All right. So that is why the domain is what? From 0 to what? Positive infinity, including what? 0. All right. So what can you say? In this domain, when f of what? 0, whatever function, what is f of 0? F of 0 is what? Is 6. So that will be what? The absolute what? Maximum. So this point here, we have what? Absolute what? Max. Okay. Is it a local min? Can we have a local min there? No, because it's at an endpoint. All right. Does it have a local absolute minimum? No, we don't even know where the points, the graph is going. So we don't know the lowest or the smallest value of the function. All right. So in this case, the function has absolute maximum value, okay, and has no absolute what? Minimum. Okay. Again, it has no local maximum or minimum what? Values. Because now again, note that we cannot have local maxima or minima at what? The endpoints. So take note of that at the endpoints. Okay, so here's the final example. What's the domain of this function? Okay, the domain is the x values. It doesn't include what? It is greater than what? 2. And then it's also less than what? Less than what 6, because there's an asymptote. Okay, asymptote. All right, at what? At x is equal to 6. So this graph goes and then doesn't cross the 6 at x equal to 6, goes up. Well, does it have an absolute what? Maximum? It does not have absolute minimum, because this point here is higher than this, but it keeps going. So we don't know. It has no, okay, it has no absolute maximum. Now, will you say that this is a local maximum? Is a local maximum? No. Why? Because the function, there's a hole. Because of the hole, there is no what? It doesn't exist. The function value doesn't exist, basically. All right. Technically, we shouldn't even write 3 and 5, because the function value at 3 does not exist. So it has no local what? Maximum. It has no absolute maximum, because the function keeps going up and we don't know its highest value. Okay. What about local minimum? Okay. Does it have a local minimum? Yes, there's a local minimum at what? X equal to 5, which is the value is what? Is 3. But does it have an absolute minimum? Again, there's a hole in that. Therefore, there is no what? Absolute what? Minimum. Okay. So we have what? The function has no absolute maximum and no absolute what? Minimum. Okay. It has only what? A local minimum value at x is equal to, which is what? 3, at x is equal to what? 5, but has no local maximum value. All right. So that is the end of it. We'll do more examples in class, and I'll see you soon. Take care.